So question 1 we have, find the volume of a solid whose base is bounded by the graphs of the functions y equals x, y equals negative x, and x equals 4, whose cross sections are perpendicular to the x-axis and are squares. So basically what we have to do is find the volume of the solid. When the cross sections are perpendicular to the x-axis, that means it's rotating about the x-axis. So it's going to form kind of like a cone if we were going to do circles. But since we're doing cross sections with squares, it's going to be sort of like a pyramid. So what we have to do is when we solve things like this, we have to find the integral of the area function. So a of x dx. And the bounds are going to be from 0 to 4 because that's the restraint that they gave, and x equals 4. So I'll just mark here, this is 4. So it's from 0 through 4 in this case. And to find area, the area is just the area of the cross section, which is a square. And a square, the area of a square is just s squared. One side squared is the area. And s in this case is going to be 2x, because from the very top of the function to the bottom of the function is x plus x, so that's why it's going to be 2x. So now if we plug s into the area, we're going to get 2x whole squared is equal to 4x squared. Now this is equal to our area function. This is a of x. So now if we plug this in, you'll get 0 through 4 of 4x squared dx, and this is going to equal 85.3 if you plug it into your calculator. And this is the final answer. Question 2 we have, find the volume of a solid whose base is bounded by the graphs of the functions y equals square root x, x equals 9, and the x-axis, whose cross sections are perpendicular to the x-axis, are semicircles. So we're going to do the exact same thing. So the integral of the area function dx, and this time the bounds is from 0 through 9, because they said it's bounded by x equals 9, which is a straight line, and this is 9 over here. So we're going to be integrating from here all the way to 9, and the area is again the area of the cross section, and this time it's semicircles. So the area of a circle is pi r squared, and since we're doing semicircle, which is half of that, we're going to divide by 2. And this time we have to find r. And we know that the diameter of the semicircle, is going to be square root x, because that's the top function and it goes all the way to the x-axis. So we know that diameter is equal to square root x. And we also know that in a circle, the diameter spans the entire length, and radius is half of that. So the radius is d over 2, diameter divided by 2, and that's equal to square root x over 2. So now we have our radius and our formula. So if we connect this back up here, we're going to get pi square root x over 2 squared divided by 2, and this is going to equal pi x over 8. So now if we plug this into the integral, we'll get square root of integral from 0 to 9 pi x over 8 dx. This is equal to 15.9 if you plug it into the calculator. Question 3 we have, find the volume of a solid whose base is bounded by the graphs of the functions y equals x plus 1 and y equals x squared minus 1, whose cross sections are perpendicular to the x-axis and are rectangles whose height is twice the base. So first of all, we need to find the bounds of integration, and this time we have to find it ourselves because it's not given to us. What we have to do is find where the functions meet. We have to find the x-coordinate of this point and this point. And to do that, all we have to do is set the functions equal to each other. So x squared minus 1 is equal to x plus 1. So x squared minus x plus 2 is equal to 0. And once you factor this out, you'll get x equal to b, -1 and 2. So -1 is this and 2 is this. So our bounds of integration is going to be from -1 to 2 of our area function dx. Now our area is just going to be base times height, because that's the formula for a rectangle, but in this case the height is twice the base, so h is equal to 2b. So if we replace this, we'll get h with 2b, so 2b multiplied by b is 2b squared. And we still need to find the base, and the base is just the top function subtracted by the bottom function, and the top function here is x plus 1 and the bottom function is x squared minus 1. So x plus 1 minus x squared minus 1 is our area. So if we plug this in, we'll get -1 to 2. And remember, 2 is outside the function, so it will be 2x plus 1 minus x squared minus 1 whole squared dx. And you see how 2 is outside because it's just 2b squared, not whole squared. So, and if you plug this into your calculator, you should get 16.2. And this is our final answer.